So hi all, I welcome you all to Microsoft Azure Pakistan YouTube meetup session for January 2023. This is the first session for this year. There are some housekeeping rules that I would like to tell before we move on with today's session. We plan to meet up at least once a month on Saturdays. The online meetings are organized using Microsoft Teams. The online meetings would be recorded and later these recordings would be uploaded to Microsoft Azure Pakistan Community YouTube channel. And I would request you all to please mute yourself during the meeting. The meeting time would be around 1 hour to 1 hour and 30 minutes. And in the end, there would be 10-15 minutes for the Q&A session. And you should preferably write your questions in the chat window, and I'll be monitoring the chat window during the session. We are part of Microsoft Azure Tech community, so there is a code of conduct that we have to follow. And you have to be friendly and welcoming. You need to be patient, be thoughtful in how you communicate in person and online, be respectful and inclusive, be open and curious, and reach out to the organizers if you need any help. Today we'll be talking about Azure AI and ONNX Runtime. And in this session, you will learn to create an AI model with Azure Machine Learning, turn it into ONNX, and use it on our favorite programming language with ONNX Runtime. And this session will also avoid exposing the model in both Python, native cloud services, or deprecated frameworks. And we will optimize it for the customer architecture that can be cloud, on-premise, or edge. And the goal of this session is to train on the cloud, and it can run anywhere. And we will see all the processes from zero to production. And the idea is to split the architecture and our company's take decisions from the customer and deploy the architecture. This session will be delivered by Mauro Bennici. He is the CTO and co-founder of UR and My Guide, GhostWriterAI. He is active in R&D area of natural language processing and natural language generation. He's a data scientist, professional Scrum Master, Microsoft certified trainer, and .NET Foundation member. He's also a member of the SME Focus Group on Artificial Intelligence in European Community. So, dear Mauro Bennici, I welcome you to today's session. And now you can start by sharing your screen, and I'm very much looking towards your session.
Thank you also for having me. So if you see my screen.
Yeah, I can see your screen.
Perfect. So welcome everyone. As said, I'm Mauro Bennici, and my first job is to be a data scientist. But my first real job was to have fun when I was 6 years old with a Commodore 64. The idea of the Commodore 64 is that everything is inside a single machine. So when I just switch on my machine, this machine starts. And this machine starts with this operating system. There is no possibilities to move. There's no possibility to automatically save on machine. I have to save all my files that I created on an audio tape, on magnetic audio tape. And every time I just restart this machine completely refreshes from scratch. So nothing is saved. Obviously, there isn't internet. There isn't any way to be to be able to communicate with other computers, and there is no way to share something from this computer to other computers. So something written for Commodore 64 had to be run to Commodore 64. So when the cloud became in a strange way when we do machine learning. Because at the beginning, the machine learning was something that we do on laboratory. It's something that we do on a special computer, and this computer is closed on data centers, or just at university, or just on a single laptop. But the data are also inside a machine. Everything from the data processing, from the analysis to the reporting, it was inside a university, inside a laboratory. So if you know our studio, this is quite much similar to what we used 20 years ago. We have Fortran. I used Clipper. But everything is inside. Also, all the data was private data. And all the software was custom software. So if my company need to elaborate something, they need to write from scratch the algorithm. And the algorithm was created also for us, and it was created for all our customers. Our customer could be able to see the report, or they also have to run all the inference on the same hardware and on the same custom software we created. Okay, this is a really strange way to work, but it was the work until 20 years ago, until 10 years ago, when the cloud started to become popular. The first era of the cloud wasn't quite different from the era when we live. Because this era was when we have a lot of software and machine on-premise, on our data center, and we simply move it in the other data center. So we are switching our data center to the cloud, using virtual machines, using SQL Server, using the first become of Hyper-V. So it's not software that were written to run with native cloud. It's just a shift. We are doing maintenance on our data center. We are moving also the algorithm, also the software to the cloud. It was not completely efficient, we know, but was the first step. When the cloud started to become more and more complicated, we start to create services to natively run on the cloud. So in this case, on Azure. So all the data that we have to create custom, all the data we have to elaborate with our algorithm, it's possible to create a pipeline on Azure and use native service. They began to have the SQL Server and the NoSQL databases. We can move through data table and files. We have the data lakes. Also, we started to say, okay, but if my data are on cloud, and I be able to clean up and to move to other kind of data, to other databases, I can also study it. We have machine learning, artificial intelligence on cloud. Yes, in this case, Azure Machine Learning Studio were born, and we say, okay, and at the end, but I can move it outside, because if I study something and this is inside the cloud, it could be a problem. It could be a problem not for my company that decided to be on Azure, but it could be a problem to catch other customers. Because at the beginning of the machine learning cloud, our company as a software company to decide when to study, because we started from greenfield. There is nothing. But now it's not the same. Our customers are in the cloud and not always on the Azure. Or they cannot move to the cloud. Like my customers are, for example, from military field or from banks. They cannot move to the cloud. So we have another kind of problem. I use Azure. I'm happy to use Azure. But I cannot use Azure because my customer want to study, for example, their data offline, or they want to run this data on something that is not Python. For example, they want to continue to use C#. It's crazy because it also means that my company have to recreate a lot of library that, for example, we have on Python on C# to study on C#. Or that the company of my customer to say, okay, I want to use C#, but I have to be able to call the API on Python, so I have to duplicate my stack. Also, this is not possible. It was not possible to be convenient for us. It's not sustainable. So in this case, the Machine Learning Studio of Azure was the first one cloud platform to say, okay, you can use my pre-created components, and these components will be able to be exported on ONNX. So the idea is, okay, what is ONNX? Okay, imagine what we have now. We have that a lot of our frameworks are in the field of machine learning, artificial intelligence. We have the TensorFlow, we have the Keras, we have PyTorch, and there are maybe 42, 43 other frameworks that are using special niche of hardware. And it's begin to be costly, because if I do research and development, I create something on PyTorch, and other company creates something on TensorFlow, it was possible to share this knowledge. So all of us have to rewrite everything, retraining everything on our framework. And this started to begin. When Google started to release something on TensorFlow and Facebook started to release something on PyTorch, also they have to rewrite everything to work on TensorFlow on PyTorch. A lot of time and resources completely wasted. So at the beginning, the ONNX Corporation says, okay, here, if I have to train something from scratch, okay, it's quite normal that I have just to choose one framework. But if I want just to run the inference, or just want to share the composition of my neural networks, just the staging and the architecture, why cannot create something like the HML format? So something that to say, this is my neural network, this is my algorithm, I want to translate from TensorFlow and PyTorch to another format. This format is the ONNX format. So the ONNX format runs like the Lord of the Rings, just to do the same, one format to share all informations about the neural networks. Because just remember that the neural networks is just this. There is no knowledge inside. We have images, we have text, we have time series data. These data are collected, are just split in little small data translated on metric number. And this number, these little points, red points, are just put inside a neural networks. These baskets just receive what activate specific numbers, and they decide that, okay, the cat is the first one, the dog is the second one. But it's only declaration and numbers. There is nothing else inside here. Also, this basket, the label of this basket, in this case, was written in Klingon. So I know the language all of us talk every day, but it's the same for the natural language. So there is no knowledge. So the ONNX Runtime was a success because all of these companies worked actively to be able to translate their frameworks, their models in ONNX Runtime. And so the convert models are born. It's the first time when they say, okay, I use this on TensorFlow, but I just export this on ONNX, and other people will be able to load again back on PyTorch. That's great. It's like a JSON format that just recreated the data, our data in our languages, the declaration of the neural network. But the question was, if I needed to train everything or to do more training on the platform, is okay that I reload everything on my framework. But just have an idea. If the only thing that I need is to run an inference, I don't need to reload everything on TensorFlow with all the structure of TensorFlow and also to be on Python. So Microsoft, at the end of the ONNX, says, okay, but if I have the ONNX format, and the ONNX format have many versions, because all many versions declare if this natively supported them some algorithm or some structure. And I can have also visualizer and analyzer because finally I can visually see the data on the ONNX. Why? I cannot create something to directly run this metrics in the language that I like. So in this case, they burn the runtimes. In this case, Microsoft start the project ONNX Runtime. The ONNX Runtime page, if you go to the website, you have this interface. This interface asks you, generally say, okay, what's your platform when you want to run the model exported in ONNX? Just say you see all the model, the platform that are supported. The API that you want to use natively, what language is it? Python, C++, C, C#, Java, and JavaScript, and also a lot are supported. Just for example, there is in Rust the possibility to call the C library. What is your architecture? And also, if you want to use the default CPU or your architecture, or the hardware accelerated. So we can use CUDA, we can use OpenVINO, we can use AMD, we can use the Android. So it's clear the idea. The idea is I start and learn what framework I want on cloud, on premise, on Azure, and just we see on the demo. And for the inference, I don't need it. I just only need to run these metrics. And Microsoft, with a partner of ONNX Runtime, writes specific SDK on my language. So in this case, I will show how to use directly in Python, and just how to use directly on C#. So all for us is just to use natively. And to use this natively, we don't have to know Python, for example, when we have just to run the inference. Or also our customers just say, okay, for me it doesn't matter what to use to train the algorithm, but my company is using Java. Okay. So the ONNX Runtime was the first most used components that now are also including other library. So when we have the TensorRT, we have the OpenVINO that was completely different kind of library. This library are reaching the ONNX Runtime platform. So in this case, it's funny because I start on Azure Machine Learning. I wrote it on TensorFlow. I export on ONNX. I install the OpenVINO library, but I can call it directly use the ONNX Runtime. So at the ONNX Runtime that do the link with the CUDA, for example, or can do the link directly with the OpenVINO of Intel. So in this case, I don't have to choice when I create my algorithm and when I export my algorithm, if they have to run on CPU, on GPU, on what else. I have to select the ONNX Runtime and say, okay, it's running on OpenVINO. ONNX Runtime check that everything is installed correctly, or just give us some alerts to fix it. And we can move it. So with an ONNX and ONNX Runtime, we can run everywhere. And so it happens now with OpenVINO. The OpenVINO says, okay, if you know that you have NVIDIA, you can run on CUDA. If you know you have an Intel, you can run on Intel. And it's able to do a multi-device clusters. So they can use more computer or networks with Xeon, for example, or he can automatically switch from CPU and GPU just to balance our job of inference. The new ONNX and the new OpenVINO, also there is a little configuration to do the training in an optimized way. So not training everything and just export and optimize at the end, but during the training, apply directly this kind of definition. So it means less resources, less time. Also, we are training our model. I think that it could be enough as introduction. We can just to see what changed for us when we are using the model. Okay, the query model is, okay, we are on Azure. On Azure, we go to the Azure Machine Learning Workspace, and we just arrive to this page. We create a new project, and the new project say, okay, what is the name of this new project? We create this. When we arrive there, we ask just to say, launch the studio. Okay, we can launch the studio, and the studio is just loading our workbench. So this is our workbench we have in Microsoft Azure Machine Learning Studio. And we can also say, okay, what we have to do, we can create a lot of automated notebooks, so for example, the automated machine learning. So there are a lot of algorithms created from us directly from Azure. That is the easy case. But just we will see what happens when we manually created our notebooks. So we are not natively on Azure, but for example, we are moving our data science knowledge to Azure. The first thing to do is that we are going to the computer instance, because the computer instance asks us just want to use. In this case, we say, oh, okay, I want to create notebooks, and this notebooks is called, in my case, it was this one, okay? It's a simple notebooks. If I want to run it, okay, oh, you cannot run it. Why? Because we didn't create our computer. So say, oh, okay, I not found nothing. I have just to create an instance. This instance could be in this way. I want just to share what I want to use. I can just say want to, just imagine is, okay, this is the machine I want to use to do the training. The most important things to do in this case is just to remember that this computer is allocated and you pay because it's allocated. So you have to switch off if you are not doing training, or you'll continue to pay. And you have also to check. It is also sometimes if you use, for example, GPU, you pay also if it's switched off. So it is better just to delete completely if you finished to train. Okay, this is the case. Okay, I'm creating the machine that you want to use. Just to have an idea, this, okay, you have to run in this moment, you cannot, but just we can look at the code. Okay, I'm starting my notebook. To start my notebook, I install TensorFlow, and just I can install another library that is the TensorFlow to ONNX. Because TensorFlow needs another components to export on ONNX the format. If you, for example, you are using PyTorch, you don't need it. PyTorch has inside the ONNX export. If you're using a precompiled model and algorithms by Azure, you have also the option automatically to say, well, I want to save it on ONNX. Okay, this is just getting starting. Just to see the code, so this is not so complicated, just to go away. Okay, we have the pandas, the NumPy, I have the Mathlib, the Skylib, the TensorFlow. But all we want to do is, I want to load the iris file just to understand what is inside. What is the iris file? The iris file is a simple file when we have 4 columns that are no dataset. It is the length of the sepal or the petal of the flower. There is the species, and the species is the type of species that define the different kind of flower. Okay? So this is okay. Thank you, my algorithm. I want to see if I provide you the information of the sepal length, or the sepal width, the petal length, and the petal width. I will provide you on the training the species, At the end, I want that you automatically be able, given 4 different features about the petal and the sepal, that you be able to understand the type of flower you are analyzing. Okay. The computer is creating, so what I have to do now is I just read the file. I gave just a little print of the file inside, there's nothing changed. I can zoom a little, I think it will be better. So it's the same, it's our Excel file loaded here. What I do is, okay, maintain all the columns that are not the species, so are the feature to be learned, and move there. And the other way would is the species. So the 3 different kind of flower, they have just to guess and just have to learn or to use. I transform the name of the flowers in something that is possible to be analyzed for a machine, just as a bit array, so not much. And just I split my dataset to say, okay, the 70% have to be used to train, the 30% have to use to test. So to test at the end of the training, is my algorithm was able to catch or not what it was trained. Just I print how many shapes they have. In this case, I create my neural network. My neural network is easy because it's okay. I have inside only one array. This is formed by 4 columns. I create a layer with 1000 of perceptron with an activation called the ReLU, doesn't format in this way. The second layer, so the first hidden layer of my neural network is 500. The third one is 300. We have a dropout of 20%, so I say randomically to put away the 20% of the perceptrons. So to say to my algorithm to learn if something is missing. And at the end I ask, we have only 3 categories. So at the end I have to have 3 values. And so the different values are the category 0, 1 and 2. The perceptron at the end with the highest value is the category that my machine thinks it is the right one. Okay? This is the idea. I just got to put on run. Okay, I'm just installing. Just run everything we see. And at the end, when they installed and analyzed the data, they wanted to be okay, want to compile this neural network and to use the accuracy. It's just to run everything, just to have the idea. And we can also move on this way. But what is important is here. At the moment, this is running, this is studying. Okay, when it was studying, it becomes to say, okay, I'm studying, I'm running, I do my train, I do my job. It doesn't matter. This is the kind. This is not easy to catch because it's going right. At the end, I have the accuracy. I know 96% of accuracy. This is all the train is changed. It's more accurate, but that doesn't matter. At the end, we'll see this graphically. That is a lot better. And at the end, I arrive here. Okay, I'm here. I'm here. What it means? What it means is that my model is completed. It's running. So my data scientist completed everything. That's great. I think, okay, but I have to run it for my customer. So my customer is waiting to be able to run it in their languages, in their hardware. Oh, okay. So the job of data scientist is, I create a tensor spec. So the tensor is if you think this is the metrics on the machine learning, and they say, oh, this is format is. Oh, this is format that we have for just columns. And this kind of columns, what is a float 32. Okay, the name that the input is input, just great fantasy. The output path, when I wanted this model to be converted, I called it sequential.onX. Okay. And this is the only line of code that we need. So I call the TensorFlow to ONNX, the convert from the chars, and just say, what is the model that I want to export? Was it a specific input? Because I know I created it from scratch. What is the offset? So the offset means the version of the ONNX I want to use, because every version include or remove something natively, and the output. Only this. Just I can call this, and what we have is something that for me exported the model. We do a lot of jobs at the end that, okay, this is exported. If you want to see it, this is quite this one. So here we have everything, the value of the metrics that we have created. Is not easy at all to understand. But because it's an open format, the ONNX could be visualized. There is a software called Netron that will be able to open our sequential.onX and tell us a lot of data. For example, there is the input. Okay. And the input, because it's visualized, where is the input in this case? This is sequential. And why not? You cannot text this before. Okay, I reload it. But the idea, yeah, because I recreated it, so it wasn't happy to be recreated when it was open. Cannot access build before initialization. Okay, just to do short. But I imagine this is the idea. This is the input. We have the visualization of our neural network. You remember we created the first one with 1000 perceptron, and we have 4 columns. Okay, now decide, okay, the input is the input name, and inside the yeah, this is a float with 4 columns. This is the kind that is Matmul. We have the add because we did the relu activation, and at the end we have the 500. So this started from 1000 and that became 500. We continue. Inside here we have the drop max, we have the sot max, and we have the dense. Okay, I know you don't like it. And we have the dense, that this is the output. What is the output? We have 3 values as output. This is absolutely the same network that we declared here. 500 perception, 500 perception is the same, rewritten, exported on ONNX. It is exactly the same that we have here. And at the end, we have 3. That's okay. This is, okay, I created on TensorFlow in the framework I want. I use the pre-trained on an Azure machine learning. I do drag and drops. Doesn't matter. At the end, I export the same. This is just an example, but okay. Now it starts. Okay. Now I'm in ONNX, but I have to use an ONNX runtime or something like that because I have to run it. Okay, the first example, we can just do I can serve it on just on Python directly here. Or the old serve that is quite the same. The only way is I have to reinstall everything. I have to reinstall the TensorFlow, the NumPy, all the library that I use in the other way. Arrive there and do the inference. I can post, I can use just the same, but I'm using the same libraries. Here we got it, okay, I don't want to use this in this way. because I have to do everything again. So that doesn't, we don't look a lot at advantages to use the ONNX if I just or to reload all the network or to reload all my job. It's useless. It's only a way for me to move to PyTorch, to TensorFlow, to TensorFlow 1, to TensorFlow 2. So the idea is, okay, but if I want to use it directly on my job, what I have to do? This is the only two things that we need. We need to install the ONNX Runtime. We need to import the ONNX Runtime and just to run the inference. So without nothing. But that's not enough because I are in Python. And we see we don't want to use Python. I want to use C#. Okay. Just I go to my Visual Studio. And I say, okay, I want to add my packages. The packages that I need to import is the Microsoft.ml.ONNX Runtime. I install this package. I create a super easy stupid console. This console called run. Here we are. So we use the ONNX Runtime, the ONNX Runtime tensor. So the special way to declare the metrics from the machine learning. And when we start, I have just to say, where is the sequential ONNX that you downloaded or you received from your data scientist? Okay. I create an inference session, just to say, okay, this is the model loaded. I create the tensor. Then this is the dense tensor, but it's the same because we see it on Netron. That is called, that is the dense, is the of kind dense. That is the same that we have declared here, is the type dense. So can you see that the power? The power is that we don't have to share anymore the source code or our machine learning algorithm. It's enough for the developers just to have the ONNX and just to open it with it's like a documentation without documentation. They open, okay, the name is input and the type is on this way, is called as kind dense. And we wait 3 of them. So I start to say, okay, the input, we have only one, we have 4 columns. Just I create fake numbers just to put something inside my tensor. I say, okay, with this value, create the named ONNX value, that is the kind of type float, this is called input. So the beginning of our neural network. I can just run, okay, just guess what is the number, what is the number of the category, so the type, the kind of flower that we want to study. And at the end, okay, take me the tensor float as an array back and give me the index of the highest value. So at the end, this is category 0, 1, or 2. So we can just run. It starts obviously to compile. Just to know, I'm using, you see, a Mac. So I'm running a .NET Core ONNX Runtime on Intel CPU, optimized Intel CPU from a model created on TensorFlow on Azure Machine Learning as Sport on ONNX. So I think it's a very strange and very long pipeline. So this is the model. Okay, just load this model. Okay, I loaded the model. Inside you have all the number on the metadata that we have see there, but just immediately, just loading, I have also the name of the input, so I don't need just to open the Netron. The Netron is I want visually to have all information are also inside the ONNX. And here, for example, we have a lot of metadata. So we can see the version of the pipeline. We can see the name of the tool that exported it. So all this information that also for us can say, oh, you cannot use this offset version because it is better to use the other one or the last one because it's more supported or not. But it's just one line on the export of the ONNX. I created the input. Just run. Okay, run. The thing ended. The result is 2. So for me, what is the result of this elaboration was just 2. This is all the output, all the things, but it's just 2. So it's the same that, I don't know just the number, but I think if I start just to change something here, so I change the way of my input, and run again, we could have, I don't know, if another number or just the same result and say, okay, but in this case, I think the result is the category 0. So just imagine you can easily get this information. We can put everything in our API and we can go without doing nothing else. At this time, it's also you say, okay, but if I did all this information and I go to the ONNX, now I'm sure that my model is working. It's possible to be catching on C#, but also I can export for what I want. In my case, I can say, okay, I have a Mac. I want to use C#. My Mac is on this way. I can just select. I can use the core ML or the full CPU. But the same model could be automatically included in an Android application, for example. I want to use Android. I want to use C#, maybe because I'm using Xamarin or Mauro. I have this kind of architecture. I can use directly the processor or the optimized directly processor machine learning core that is inside the Android. Same way iOS or Linux, I think I have a lot of more opportunity. So it doesn't matter. It's just to run. So I can create many different kind of applications optimized directly for the kind of hardware, software, and platform my customer want to use. And on my company create a specific target of text to speech and speech to text. Especially the speech to text is deployed completely offline inside an Intel NUC. So because my company cannot go to the cloud, they cannot use the server, they have an Intel NUC just connected during, for example, a meeting of the board, and everything is registered, transcribed, translated inside an Intel NUC. But all our job is trained on the cloud, on Azure. On the same way, for example, also there are other optimization also for Android. For example, if you have and you know that you are going to deploy something for the Snapdragon CPU, there is also the optimization for the Snapdragon CPU on Android. There is also a possibility to automatically switch from CPU and GPU on natural language optimization on Android if we have, for example, a pixel for Google. And also we have OpenVINO that we know that are optimized from Intel, but also it's created the possibility we have in the community to run the OpenVINO directly from HARM. Because it is useful to use OpenVINO, because OpenVINO also create with Intel the optimized version of the Python compiler the TensorFlow version and the PyTorch version. So if we know that we are running on CPU, created from Intel of the ARM, we can also use the specific compiled version of Intel of their framework. Also, this in Azure. So if in the computation we select Axion, or just start from the second version or the third or the fourth, we can say, oh, okay, I know that I'm running on Azure. Also, I want to just to expose my API on Azure, but if I select something that is directly in Intel, I can also optimize because the calls are directly due for the register of the CPU of Intel. And this without do absolutely nothing. Install OpenVINO, use ONNX Runtime, all the magic is for free. So I think I talked a lot. If you have a question, I'm here for you.
Thank you so much, Bruno. It was a very interesting session that you have delivered. And I'm looking into the chat window. And I'm not able to find any question, but I have some questions related to your session. I would like to know that do you think this ONNX is faster than PyTorch or TensorFlow?
Okay, in generally, when we export something on ONNX you can just say I want the conversion 1-to-1. So this is not faster because it's just the same. Or when you start an ONNX, or just you can just select if you want to optimize your model. So for example, you cannot need to use the float 32. I want to use an integrate. It do all the quantization, all this operation is made automatically. Obviously, we have to check if the accuracy is the same. For sure, the resource is 70% less because it's just optimized to run. But it's just a decision that we have when we export something. Okay. So when we see the line with was just TensorFlow to ONNX save, we can add a lot of other information. There is thousands of options. One of these options is it's okay, optimize it for me, just removing something that is useless or change the type of the inter or the metrics. Yes, the ONNX runtime optimized in quantization is really, really, really fast. And also, if you use OpenVINO is 2 or 3 times more faster than the ONNX runtime without OpenVINO. So just to do an example of my company, just starting from scratch, the training, if you get that the training is 1x, when we run directly optimizing ONNX and ONNX and an OpenVINO at the end, there is 5 to 6 times faster. It's crazily fast. It's crazily fast because it automatically remove everything. But in this case, we cannot reload, obviously, for example, on TensorFlow to continue to train or to fine-tuning our model. Obviously, it is not possible because the original data was completely lost during the conversion.
So if ONNX is running some kind of optimization on the model, does it also reduce the size of the model?
The ONNX runtime, no. The ONNX runtime is just to run. So it's just to use iLoad and run. Okay. The ONNX runtime could be if you use the ONNX runtime to do the training, but it is another way because ONNX runtime to the training it works only on PyTorch.
Okay, so you can actually train your model on ONNX runtime, but it should only be in PyTorch.
Yeah, to do the training, only in PyTorch. If you want also to train on TensorFlow, OpenVINO support it, but you need to have an Intel Xeon on Intel CPU. Okay.
Yes. Well, there are no further questions in the chat window. So I would say that Mauro Bennici, it's a pleasure to have you on board, and it was really interesting to listen to your session.
And, thank you for having me.
Yeah, I hope you will also give us your precious time in future. What I will do now is that this session is being recorded, and the recording of this session will be uploaded to the YouTube channel. And I will also send you an email so that you can reference to it if you want. And
Yeah,
thank you
that's
so
great.
much. Yes.
Thank you too. Thank you too for having me. And if you had the other have a question or want just to ask something, you can just reach me on LinkedIn, on Twitter. I'm
Yes.
happy to share to share with
Yes,
you
sir.
and just to.
There is one. There is. I also have one question. What was the name of the visualization tool that you showed, in which you were in?
Okay, yeah, I put on chat.
Yeah, that would be really
See,
good because that was very interesting.
yeah, this is called a Netron.
Network. Okay.
Yeah, it is open source. You find it on GitHub.
Okay. Perfect. Perfect.
Yeah, because it's very useful just also to compare different models on just to have a check if the export, for example, it was made good for you. Because sometimes, okay, I exported, but the other side will say, oh no, my version of the framework, that is ONNX Runtime, OpenVINO, doesn't matter, it doesn't support the version 11, or they want to use the version 12. So it's easier to see, you catch it, oh no, re-export me, please.
Well, thank you so much, Mauro Bennici. It was really interesting. At least I have learned a lot during your session. And thank you to you and also to all the people who have attended this session. So have a very nice evening, night, morning, wherever you are, depending on your time zone. And see you in the next session. Thank you so much. Bye.
Will be a pleasure. Bye. Bye bye.